and let's try to do something better here. Now, first of all, what do we say if we come across somebody who asks us a question, for example, what is differentiation or what is a derivative? What are we going to tell the person? So this is what we have to discuss. Now, so when you were in grade 11 or grade 10, you did something called gradient. Okay? You did something called gradient. I believe you remember something like that. Do you remember gradient? But in grade 11, you did not only do gradient, but we do what we call average gradient. So in grade 11 or grade 10, you do what we call the average gradient. And this average gradient is known as the slope of a straight line, okay? Slope. Slope of a straight line. But today, the derivative that we're going to do is not only the slope of a straight line, but is the gradient of a curve at a point. So the gradient that we're going to be talking about today is what we call differentiation or a derivative. And it is the slope of a curve, but at a particular point. So we're talking about a point here. Now, so this is where we come to. All this is what we are going to be talking about. For example, if you have a curve, look at this curve. When you resume school, you are going to look at some of these curves. This is a cubic graph, for example. So this graph here has a number of curves on it. If I have a point on this curve here, I can basically attach a straight line. This straight line here, as you can see, is a straight line here, and it meets the curve at only one point. Now we want to find the gradient of this curve, okay? We want to find the gradient of this curve, but at the point at which the tangent meets the curve. So that is what we're going to be calling the differentiation or derivative. So as you can see, you have a straight line, okay? And then you also have a curve. If we find the gradient of this straight line, we call it the average gradient here. And then if we find the gradient of this curve, okay, this particular curve, if we find the gradient of this curve, but at a particular point on this curve, then we call this type of gradient a derivative. And a derivative can come from first principles, or it can come from what we call the rules of differentiation. So we need to first go straight into our lesson to be able to understand what exactly we can do when we come to our final metric exam. Now, take this for example. Differentiation can be done from rules and can also be done from first principles. So what we're going to do in our today's lesson will be based on the rules of differentiation. So take note. Now, whether you are using the rules of differentiation or you are determining the derivative from first principles, both answers must be the same. Different methods, but the same solution. So let's start our lesson. A derivative is done when we have a function or an equation. For example, if I have y is equal to 2x plus 3, this is basically an equation. An equation because we have a y here. If I have f of x, g of x, or h of x is equal to 2x plus 3, then this basically becomes a function, because f of x, g of x, or h of x is called the function notation of x. I can write it down for you. Function notation, okay, notation of x. So when we have g of x, h of x, s of x, is called function notation of x. So once we have a function notation, we call the whole equation a function. It is no longer an ordinary equation. So if you have y is an equation, if you have g of x, h of x is a function notation. Therefore, it is a function. So these are some of the things that we can find the derivative for. But how do we go into finding gradient at a point? You see, we are finding the gradient of a curve at a point. So take note of that. We are finding gradient of a curve at a point. Okay? Now, so let's take an example. I have f of x is equal to 10, for example. Now, in this case, f of x is equal to 10. This value 10 here is a constant. Now, why do we refer to 10 as a constant? It does not have any relationship with an alphabet or a variable. For example, if I have 10x, then 10 is no longer a constant. It is now a coefficient, okay, coefficient of x. Okay, so the 10 here is a coefficient of x. But if I have 10 and there is no alphabet attached to it, then we can call this one a constant. I want everyone to take note of that, because these are the things you need to know before we move to the next level. So 10 here is a constant. So I can tell you one thing, that this is a mother rule everybody must know, that the derivative of a constant is equal to 0. If you permit me, I'll write it down. Okay? Derivative of a constant, okay, is equal to 0. Now, so it means anytime that we are finding the derivative of any constant, the result is 0. I want everyone to pay attention. Now, so for example, if I have g of x, okay, if I have g of x is equal to 25. Now, this 25 is a constant. So a derivative, you know, in English, we have what we call the exclamation sign. Now, we also have what we call the apostrophe. So when we use the apostrophe, then we call that one a derivative. So guys, take note of that. It is this symbol up here, the apostrophe symbol, that tells us that we are doing what we call derivative. Okay. So this symbol here is what we call the derivative symbol. Okay. So for example, if we have g of x, if we have g of x is equal to 25, then the derivative will be g prime of x is equal to 0. Why are we saying this? We are saying this because the 25 here is a constant. So if 25 is a constant, and the rule says the derivative of a constant is equal to 0, then basically anything that we have which is a constant, when we have the derivative, that is the apostrophe symbol, we are basically going to get 0 as the result. Okay. Now, look at this example here. You have f of x is equal to 10. The 10 here is a constant, so your guess is as good as mine. What is the derivative of 10? Or what is the derivative of f of x is equal to 10? The result will be f prime of x, because the prime symbol here tells you that you are doing a derivative. Then 10 is a constant, so the derivative is 0. So that is one thing. I believe as I'm writing, you are also copying so that we can move on according to time. Now, so that is what we call a derivative of a constant. So anytime you have the derivative of a constant, obviously the answer is equal to 0. Now, before we move on, if I say I have y is equal to -3, the -3 here is your constant, okay? It's your constant. So we already know that the derivative of -3 is 0. But we do not find derivative of the constant alone and leave the subject. This is our subject, right? The subject of the equation. So this is our subject. Okay, so if we have to derive both left-hand side, okay? Both left-hand side and then the right-hand side. Okay, so now what we're going to do is the derivative of a y, the right-hand side, will become dy over dx is equal to -3. But if we have f of x is equal to -3, obviously you will have the derivative will be f prime of x is equal to 0. So these are the two things that you need to consider when you are working with a derivative. You need to take note of that as we move along. Always try to take the information and you know what to do next. Now, let's come to a very important stage in differential calculus. In exam, you can be given a function, for example, f of x is equal to -5 x to the power of 7 plus 12 x to the power of 4 minus 10x. This is where we need to remember there is a mother rule I'm going to give you, learners. Write it down. It is important that you write it down. We call it power, okay? Power times base, okay? Let me block this one for you. Then another one is power minus 1. So power times base, then power minus 1. Take note of this rule. You love it. You are going to love this. You see, a base is basically a variable or a constant that carries a power. Now, when we look at negative 5x to the power of 7, since x is the one carrying the power, look at this. So x becomes our base. Take note of that. I'm making this clearly so that everybody can understand. Since the x here is the one carrying the power 4, then our x here, okay, becomes our base. And here, x here is the base. Now take note that x here has a power of 1. Don't forget that. So I'll rewrite it down so that everybody gets the insight of what we are doing. So f of x equal to negative 5x to the power of 7 plus 12x to the power of 4 minus 10x. Now, so what we're going to do is, guys, just follow what I'm going to show you now. This is the subject. This is the subject. So the subject, we can find a derivative of the subject. So the derivative of the subject will be f prime of x. Now use this rule. Use this rule I have given you here. Are you following? So take the power is 7. Multiply it by the coefficient of the base. Okay? So the base is x, but the coefficient of the base, I mean the number that is multiplying the x, is negative 5. So I will write it like a statement for you so you have it. So the power is 7 times the base, the coefficient of the base will be minus 5. Are you getting it? Then we have x. So let me just do it like this for you. Then you come to the other point here. You take the power, but you subtract 1 from the power. So we know that the power is 7 here. If you subtract 1, so this also is there for you. Then you are done with part 1. We come to this one. So the power here is 4. So I will say 4 times 12. Okay? Then I bring the x. Then I have to say the power now, which is 4 minus 1. Take note of that. Then we are done with that part. We go to the third part. We have minus. Now the power of x here, since there is no number written here, the power is 1. If a variable does not have a visible power, it means the power is 1. So I will say the power of x, 10 minus 10x is what? 1. The coefficient of x is negative 10. Okay? Then I have my x, but I must subtract 1 from the power. The original power here is 1. So I have to subtract the power. Okay, guys, look at it now. Let's do our calculation. So we have f prime of x is equal to negative 5 times 7 is negative 35. Then we have x. 7 minus 1 will give us 6. Then 4 times 12 will be 48, right? Okay. Then the power is 4 minus 1, so the power becomes 3. Negative 1, okay, let's say negative 1, you know, outside the bracket there is a number here. It is not visible, but you know that when the number is not visible there as a product is 1. So negative 1, but 1 times negative 10 is negative 10 here. Negative 10 times 1 will give us positive 10. So the power of x here is 0. The power of x is 0. Are you following it? Okay. But what is going to happen now is that, guys, something quickly. We need to check something. Have you seen that when we are doing our computation here, we repeated the negative? So this is one of the things that you have to do when you are working with calculus, because the problem now is that we have only one negative here, but when we come here, there is double negative, which tells you that when you are doing algebra, the expansion, you need to be very careful with your expansion. So this negative is here, but you can have your positive 10 here, because we have only one negative value, which means that negative 10, obviously, it means that mathematically you have plus 12x plus, then you have negative 10x. So here, instead of having a double negative, what you need to have will be positive 10 times negative 1. So this place now will become negative, but not positive. Are you following? So obviously, we need to say we have f prime of x is equal to negative 35 x to the power of 6 sorry guys, I think there's a problem with the writing there. Let me bring it closer here. I have f of x so that everything can be clearer, minus 5x to the power of 7 plus 12x to the power of 4 minus 10x. Okay, so now let's say this. We have f prime of x is equal to negative 5 times 7. Okay, then x has the power of 7 minus 1 here. Okay, then we have plus 4 times 12. Okay, then we have x to the power minus 1. Now we are redoing it, so everybody is going to get a feel of what is happening now. Now the power here is 1. This is where we need to be very careful with. So let's say we have minus here, but we cannot repeat the minus again. So we can now have 1 times 10, okay, x to the power of 1 minus 1. Okay, or you can write it as f prime of x is equal to negative 5 times 7, okay, or 7 times negative 5, x to the power of 7 minus 1, plus 4, which is the power times 12, or 12 times 4, then x to the power of 4 minus 1. Then here you can say, since the power is positive 1 originally, you can say plus, you see. Then you have 1 now times negative 10, okay. Then x has a power of 1 minus 1. So these two are workable. There was no much space at the bottom initially on the previous page, so I have to wrap everything to make it clearly. So now let's go. So we will see that if we have f prime of x, okay, here this will give us negative 35. This is also giving us negative 35. So we have negative 35, okay. Then x, 7 minus 1 is 6, 7 minus 1 is 6. So you see the two equations will give you the same value. It depends on how you want to work it out. So this will give you 6. Then 4 times 12 will give us 48. Okay. Then we have x. Now our x has a power of 3. 4 minus 1 is 3. So I have 3 here. Now, here you see, 1 times 10 is 10, times negative 1 is still negative 10. And then, if we come to the second part, we have 1 times negative 10 times positive 1. So it will give us negative 10 also. So it doesn't matter which method you use. But look at it, 1 minus 1 is 0. So look at it here. Now, there is a rule from primary school which says a variable or a constant that has a power of 0 gives you the result to be 1. So x to the power of 0 is 1. Now, remember, if this whole thing is 1, 1 times negative 10 will give us negative 10. So, obviously, I can write it like this, okay? F prime of x is equal to negative 35, okay? Then x to the power of 6, then plus 48, okay? Then x to the power of 3, then 1, this is 1, x to the power of 0 is 1, times negative 10 will give you negative 10. So this becomes your answer, your final answer for this question. All right. So take note of that before I take it off. All you have to remember is make sure that you subtract 1 from the power after multiplying the power by the coefficient of the base. Now, take this for example. You have y is equal to x over 5. So what happens is that you first need to realize that there is a coefficient of this x here. And the coefficient here is 1. Guys, take a note of that. This is the question. Okay, y is equal to x over 5. So you are supposed to find the derivative of this using the rules of differentiation. So make sure that the coefficient of x is known. The coefficient, if the coefficient is 0 here, then x times 0 is 0. Then we'll no longer have x. So know that the coefficient here is 1. Okay, so in order to write it properly, you have to say the coefficient of x is 1 divided by 5. Then you multiply it by the x. That is the first thing you need to do. This is the basic thing you have to do before going on. Now, you also have to remember that the power is not written here, meaning the power is 1. So what do we have to do? We use the rule, power times base, power minus 1. So remember the derivative of y here can be written as dy over dx. So if the derivative of y is dy over dx, then obviously we take the power, we multiply it by the coefficient of the base, okay? Then we take the power again and subtract 1. So if you get here, your calculation will be easy, right? So 1 times 1 over 5 will give you 1 over 5, okay? Then 1 minus 1 is 0. So see that. Now we are able to say that dy over dx is equal to 1 over 5 times what? 1. Remember I told you something, that any variable or number that has a power of 0, the result is 1. So x to the power of 0 is 1. So 1 times 1 over 5 will give us 1 over 5. Okay, guys. I believe as I'm talking and writing, you are also writing because of the limited time we have at our disposal. Okay. We'll take another example and then work it out. Look at this one. Y equal to let's say y equal to 4x over 3. Okay, y equal to 4x over 3. So y is equal to 4x divided by 3. So we want to find the derivative of this. So the first thing we have to do is to say y is equal to 4 over 3. Remember, I always tell you that take the coefficient of the x and the denominator and put it aside. So this is what we have. Then we know that the power, if nothing is written as a power, take note that the power is 1. So what is the derivative of y? dy over dx is equal to the power, which is 1, times the base, which is 4 over 3. Okay? Then we take the power and subtract 1 again. Now we have dy, okay, over dx will give us 1 times 4 over 3 will give us 4 over 3. Then x to the power of 0. And we know that anything to the power of 0 gives us 1. So dy over dx is equal to 4 over 3 times 1. So the final answer will be 4 over 3. So that is the solution for that one. So again, if it was g of x is equal to 4x over 3, all right, all you have to do is to say your g prime or g of x is equal to 4 over 3x. Then after that, you will say g prime. If you bring the symbol, the apostrophe symbol, it is only then that you can call it a derivative. So the final answer will be 4 out of 3. And remember, if, for example, I am given a question and I do not put the derivative symbol here, then it means the solution is a wrong one. For example, if this question, I am doing a question like this one, and I say the derivative is, for example, if I write g of x is equal to 4 over 3, this is wrong. It's completely wrong. Why? Because it does not tell us what we are doing. But if we put the derivative symbol, it means we are deriving. And what is derivative? It is the gradient of a curve at a point. I'm stressing on that because there are two types of derivative, from first principle and from rules. Okay? And also average gradient is the gradient of a straight line. But the derivative we are doing is a gradient of a curve at a point. Okay, let's take one example here. This one looks simple, but it is very tricky. It is indeed tricky. If you look at this, the denominator has to do with x. It is the opposite, the direct opposite of the first example we did. So this one, if we draw a graph, it will draw a graph that has to do with a hyperbola. Okay. So it is not a straight line. The first one we did was a straight line graph. So all you need to do is to convert, okay, take note of it, write it down, guys, convert into positive, it is already positive exponent, okay, so convert it into negative exponent. exponent. So what am I saying? The power of x here is 1. You can see that. So we are going to make this power to be -1. So whenever you have a function where the denominator has to do with x, don't derive it straight away. You need to convert it into a negative exponent, because it is originally a positive exponent if it is a hyperbola. So g of x, okay, will be equal to, now take note of this. What is the coefficient here? The coefficient here is also 1. So the coefficient of x is 1, the numerator is 1. So you are going to say numerator divided by the coefficient of the denominator. 1 divided by 1 is 1. So we have 1x. Then the power here, I will convert it to become -1. That is the first thing you need to do. Okay. Then after that, all you can do now is to derive. So g prime of x, okay, is equal to, what is the power? -1. What is the coefficient of the base? +1. Then you say the power here, which is -1, you subtract -1. So now what we're going to have is that your calculator will tell you that g prime of x, okay, will give you -1, because this time -1 times 1 is -1. Then if you subtract -1, if you subtract 1 from -1, it will give you -2. Or if you say -1 minus 1, it will give you -2. So obviously your g prime of x will give you -1x to the power of -2. All right. So this is one example that we need to contemplate on. I'm giving you a few seconds to write it down. Then we take the next one. And it depends on how we progress with our lesson, and everybody will be able to enjoy it. But guys, there is something I want to tell you. Remember that the question is of a positive exponent. Our solution is a negative exponent. You are at liberty to convert it back into positive exponent. But this is your final solution. It is always good that if the question is in positive exponent, you convert it to positive exponent back. Okay, so let's see. Now, I want to change this power, -2, to become a positive power. I will do this. Look at it. I will first say x to the +2 power. That's the first thing. But it must become a fraction. So I will then put the negative here and put the 1 on top. I will do another example quickly so that you know what I'm explaining to you here. Okay, so I urge you to write down everything. If you like, you take screenshot of the lesson so that you'll be able to do another one. Okay, so let's say this. Let's say I have y is equal to 6 out of 5 x to the power of 4. Now, take note, this one is hyperbolic also, because the denominator has to do with x. So what you can do is to first change this power, okay, convert to what? Negative exponent. So convert, okay, to negative exponent. Okay, so after converting to negative exponent, then you can proceed to derive. So y is equal to, now how do we convert to negative exponent? Take the numerator, divide it by the coefficient of the denominator. So 6 over 5 will still give us 6 over 5. Don't write it as a decimal, okay? Then the power is positive. Positive 4 becomes -4. Now, how do we derive now? So we are finding the gradient of a curve at a point. That is the meaning of derivative. Okay, what does the rule say? Power, which is -4, times base, which is 6 over 5, because that is the coefficient of the base. Then we subtract 1 from the power. Are you following? Okay, so this is 4 minus 1 here. All right, so let's do our calculation. -4 times 6 over 5. So dy over dx is equal to -4 times 6 will give us -24. So we have -24 divided by 5. Then we have x to the power of -5 here. So we'll have -4 minus 1 is -5. So this is what we have. But this is the final solution. If you want to convert this into a positive exponent, meaning we want to convert this power to become positive, just like the way the original power was positive, it is simple. We can just have dy, okay, over dx is equal to, then we have, now you see, in the previous example, I told you that take the numerator, the coefficient of the base, and make it a numerator. So, but here the coefficient is a fraction. You don't take the entire fraction, take the numerator of the fraction. Guys, take note of that, the numerator of the fraction. So I would then have to say x to the power of +5, because I want to convert that positive -5 to +5. So the numerator will just be the numerator of this fraction. Don't write all the 24 over 5. But there is something here. There is a negative sign here. So I will put the negative sign in front. But this x still has a coefficient of 5. So I'll write it there. So this is how you write the solution for this example. It is important that you copy it, take it down, and see how best we can proceed. I do not know if we have enough time on our side. If the moderator says we have time, I can still do one more example with you learners. I love to show you all these things because it is one of the challenging aspects of your curriculum. Am I permitted to move on?
Thank you, Victor. And in prim, I just wanted to check with these students if they have any questions. If they don't have any, then probably we can go with one more.
Okay. Learners, we want to have your opinion. Is there any question you want to ask, or is there anything you want to say about what we are doing? So we can do one or two more examples before the session comes to an end.
People, don't be shy. If there are any questions, you are always welcome to ask it, because that's why we have Victor here who can clarify all your doubts.
Is there any learner here who wants to add something or to ask a question? Okay, otherwise I'll do one more example if that's fine.
Sure, Victor. Yeah, we can go with one more.
Okay, let's take another example. We have f of x, let me just say y is equal to the fourth root of x to the power of 7. Then we have plus, we have the square root, the cube root of x to 8x to the power of 5. Then we have the fourth root, okay, of 4x all to the power of 2. Now, learners, I want you to be careful with this example. It's going to be a bit tricky. So the first thing we need to do, write the question down, and we continue. So we can have y is equal to, we have, now I want to see if you can see this technical problem. This is one thing you need to understand. Is that correct, learners? There is nothing like this. In maths, you either have y or you have what? F of x or g of x or h of x. So this is what you cannot have function notation of y here. So take note of that. So I can write it as f of x. And here too, I can write it as f of x. If you don't want to write f of x, then you have to say y is equal to. All right, that is the first thing. I'm trying to show you how learners can make mistakes and they won't know that they are making mistakes. And in exam, they are penalized for that. All right, what do we see here? We see a set. So here too we have a set. Here too we have a set. So we need to work out the set. All right, so this becomes x to the power of 7 times 1 over 4. So it gives us 7 over 4. Then when we come here, we will have 8x, then 5 times 1 over 3 will give us 5 over 3. Then remember there is an issue here. You need to sort it out first. Let me do it here for you. For example, if you have 4x all squared, then you have the fourth root. The first thing is to solve the bracket first. So we will have 4 to the power of 2 will give us 16. Do you see that? So 4 to the power of 2 will give us 16. Then x has a power of 2. But we have the fourth root. Remember that. Okay? All right. So obviously, if you bring this here, you can have 16, okay, times x. Then the power becomes 2 times 1 over 4. So what is 2 times 1 over 4? It will give you 2 over 4, which can give you 1 over 2. Are you getting it? So it is one thing you need to talk about. But remember something. Even this power, this 6 here, is also affected by the root. This is what you need to remember. So we also have 1 over 4 here. All right. So I will do that example again. Guys, it is a very tricky situation. You need to understand it. So we have this. So 4 times 4 to the power of 2. So let me do it slowly for you. So we have this here. Then I have 4 to the power of 2. Okay. Will give us 16. X to the power of 2, because the x also has a power of 2. So we have that. Then now we have f of x again is equal to x to the power 7 over 4, okay, plus 8x to the power of 5 over 3. Now, the root here affects the 16 and affects the x to the power of 2. That is what I'm trying to tell you guys now. Okay, so if you have that, it is possible to just say minus 16 to the power of 1 over 4. Okay, which can be simplified anyway. Okay, then x, now x to the power of 2 times 1 over 4. So it will give you, like I said, 1 over 2, because 2 times 1 over 4 will give you this. But we all know that 16 to the power of 1 over 4 will give you 2. Your calculator can tell you that. Okay, I'm talking talking about the whole of this. Use your calculator to solve it. Just say negative 16 to the power of 1 over 4. It will give you negative 2. So you just write it down. Okay. There are many ways of doing it. I can show you another trick, but because of time, I would limit it to these examples. So I have 8x to the power of 5 over 3. Okay, this is 3. Then I have minus 2. Then I have x to the power of 1 over 2. All right, so basically, this is what is nice about this. The nice thing is that we have a technical error here. I just don't know if you guys are seeing what I'm doing, because when you put a derivative, it means you are multiplying the power by base and subtracting 1 from the power. Are you getting it, guys? So there is no symbol here. This is what you need to take note of. I will show you all these tricks. You need to know it, because in exam, at the marking center, what we do is that every error that you put in destroys whatever you are doing or nullifies what you're doing. Okay, so there is no derivative here. So what do we do? Let's go on now. So the derivative will be power times base power minus 1. Now we can bring the derivative symbol. Okay, so the power now is 7 over 4 times 1 will give us 7 over 4. Okay, then x, we subtract 1 from 7 over 4 will give us 3 over 4. Guys, use your calculator and check my values so that if you are able to get the correct values, okay? Because we are not using our calculator here. We are just trying to use our brain to do the calculation. Then the next thing is take 5 over 3. Okay, this is 3 here. Take the 5 over 3 and multiply it by the 8. So if you take 5 over 3 and multiply by the 8, what are we going to get? Is it 10 over 3? If it is, then you write it down. So 10 over 3. Use your calculator. 5 over 3 times 8. Then we have to subtract 1 from the power. 5 over 3 minus 1 will give us 2 over 3, right? So 2 over 3 here. Okay, I want to write it clearly. Then we have half here, 1 over 2 times negative 2. Use your calculator. Half times negative 2 should give us negative 1. Okay, then negative 1x, but I'll just write negative x. You know, in maths, where you have negative x is the same as negative 1x. Okay, then we have to subtract 1 from the power. So you see, we have 1 over 2. If you subtract 1 from here, you will get negative 1 over 2 here. So basically, if you are struggling, you don't know what to do, the best thing is to leave your answer in this form. But it is always proper to reverse your solution in a third form or in a positive exponent form. So let's patiently see how best we can write this. But as I tell you, the examiner is satisfied with this solution. All right, here we don't have a problem. Everything is positive, so we don't have to force ourselves to write it as a positive exponent again, because the power is positive. But there is a third here. You see, the denominator, you see, this is a rational exponent. So the denominator here, which is 4, becomes your third. So if I say, what is your third here? You see, it becomes the 4th root. Okay. Now, so I have 7 over 4. Okay. Then I have a third here. And what value is the third? Here is the third. So that will be 1 over 4. Okay. So 1 over 4 is the root here. That is the 4th root. So the x still has a power of 3. That is what it means. So the numerator of the x becomes your power here. This is my x, okay? So x to the power of 3. Then we come to the next point. We have plus here. The power is already positive, but the power again is a fraction. It's a rational exponent. So a rational exponent can be written as a set. So I have my 10, then I divide it by 3, then I have x here, okay? It looks like k, but it's okay. Then I then have to see what is the set here. The denominator is the set. The value of the set is 3 here. So it means we have the third root. You see, permit me to write it somewhere here. Yes, good. It's fine. That becomes the third root of x, but the numerator is 2. So the numerator of x is 2. All right. Then here, the power is a negative value. This is where we need to remember something. So I will maintain this negative 1 here first. So this negative 1 becomes a numerator. We did that in a previous example, that if the power is negative, take the coefficient of x and make it the numerator of the function. So that negative 1 is now here. And then it means that once I put this numerator and put the division line, the power here is no longer negative 1 over 2, but it is positive 1 over 2. And what is this? 1 over 2 is a rational exponent here, so it is a set. What is the value of the set? 2. So I would have the second root of x, which we call the square root of x. And if it is a square root, you don't write the number 2 there. So that is one of the things that we need to see how best we can work with them. Guys, it is very important to note that calculus is a beautiful area to get into, but the only thing that can cause you to get low marks is the technical errors. I have been able to insert technical errors so that everyone will know at what stage do you make an error and you are given low marks, and at what stage can you identify your technical errors and correct them. I have been able to do all that in this lesson, and I just want to say thank you very much for listening. And I believe that when we are given the opportunity again to organize this program, it is going to be fantastic because we have more sections of calculus and more hectic aspects to cover. Thank you very much for listening and watching.
Thank you. Thank you so much for your descriptive and more informative session, Mr. Victor. I believe definitely students would have got some benefits out of it, and definitely they'll be able to understand differential calculus in much more layman's language and more easier too. So students will also be sending out a survey to your email shortly. Probably you can put your honest feedback on how this session was, and based on your feedback, we'll be able to arrange for sequential sessions in regards to differential calculus and other topics too in mathematics. And Mr. Victor would be happy to help you guys through the presentations too. So thank you so much
Yes,
for your time.
thank you
Yeah,
very much, Romuald. And I want to encourage learners again that if it is something that is encouraging and inspirational, they should go out there and tell more learners to get on board.
definitely. You can refer to your friends as well as to your colleagues, I mean, your school friends too, and your classmates who are doing mathematics with you, so that it'll be easy for them also to understand. And moreover, they'll also get some insights about differential calculus and other topics in the mathematics as well. So thank you everyone for your time and patience. And we appreciate everyone who participated in this session. And definitely we hope that it is informative for you guys. We thank you one and all, and we wish you a very happy day as well as a weekend. Thank you. Thank you, Victor.
Thank you very much.